Anyway, so here we're going to be trying to find x. So this is a side, so that's the first thing on our list that we need to know. So first up, we need to figure out which sides am I using here. If this is the angle I'm looking at, what side is this?
Sine.
Yep, it's our opposite. What's this? Great. So I'm using saw, car, toa. Which of the three do you think I'm going to use? I'm going to use sine. Cool, because it's the only one that has an O and a H. So sine is equal to opposite over hypotenuse. So now I'm going to fill in my blanks. So instead of this, I'm going to write 33 because that's my angle. My opposite side is x, and my hypotenuse is 261. Cool. Now when I have my number on the bottom, what do I do?
You take it to the other side.
Awesome. I bring it to the front. So in my calculator, I'm going to be typing 261 sine 33 is equal to x. Now I can put a multiplication sign in here if I want to, but calculators generally will work even if you don't. So that's a multiplication, not a plus. Cool, so I typed that into my calculator. Oh,
I'm sorry, 142.15.
1.15. Coolsy, so that's how big this side is. So the answer is 142.15. Great. Any questions about that? Now let's do this one. So first up, I want to identify what sides of the triangle I'm using. So this side over here. Great. It's our adjacent side. And what's this one here? Hypotenuse. So soc toa, which am I going to be using? I'm going to be using ka. And ka means cos, which is equal to adjacent over hypotenuse. Okay, so now I'm going to fill in my blanks. What am I going to put? 19, which is my angle, and my adjacent side is
8.
8. My hypotenuse is A. I should have called it H, but anyway. Now, what do you notice that's different about this question and this question? Great, the numbers are in different spots. Here the numbers on the top, here the numbers on the bottom. When the number's on the bottom, I can move it, but when I've got a letter on the bottom, I can't just move it, I have to swap. So that's going to go there, and that's going to go there. So my A is put up to the front. The top of my fraction stays the same, but on the bottom is now cos 19. Great. I type this gibberish into a calculator.
0.46.
8.46. Any numbers after the 6?
0.9.
Cool. Alright, so it stays that. Awesome. And that is how big our hypotenuse is. So it'll be 8.46. Great. Any questions about that? No? The important things to know is if your number's on the bottom, move it to the front. If your letter's on the bottom, swap them. Cool. Cool. Now we're going to do one where we're using tan, but to start off, it's always good form to label your sides. What is this side down here? Cool. And what's this one over here? Cool. So I'm looking for one of these that uses an O and an A. It's tan. So tan is equal to opposite over adjacent. So I'm going to fill in my blanks. So instead of this stupid symbol, what am I going to put? 27. What's my opposite side? Over. Great, which is 54. Great, my number's on the bottom, so what am I doing? Cool. Moving to the front.
27.5.
Great. Awesome, thank you. So x is equal to 27.5. Great, now I want to try and find angles. So that's what I'm missing. I've got two sides that are given, but I don't have the angle. So, as always, I start by labeling my sides.
Cos.
So, what side is this?
Adjacent.
Great. And what's this one?
Hypotenuse.
Oops, that's a terrible looking H, bless you. Which am I going to be using? Soc, car, or toa?
Cos.
Cool. So, cos is equal to adjacent over the hypotenuse. So I'm going to fill in my blanks. Do I have one of these? No, so it's going to stay the same. but what side? What is my adjacent? 56 over 51. Cool.
75
Now, when I'm
degrees.
finding something inside my triangle, when I'm finding an angle, I have to use inverse. So remember, inside equals inverse. That's what you need to know for angles. So because I'm finding something inside my triangle, I have to use inverse. So in my calculator, I hit shift before I hit cos, and that will give me cos with a little -1, and that means inverse, meaning inside. So now I'm going to type in, then my fraction. Usually your calculator will automatically give you brackets. So you hit shift, then cos, it'll give you cos with a little -1, and then you type in your fraction, and my answer is
75 degrees.
x is equal to 75 degrees. Any questions about that? No? Let's do this one. So, what side is this?
Hypotenuse.
Great. What side is this?
The opposite.
Great. So which am I using? I'm not using cup this time. I'm using sin or sine, whatever. So, sine is equal to opposite over the hypotenuse. So I'm going to fill in my blanks. Do I have an angle? No. I've got this weird symbol. So what's my opposite side? 311 over 481. So because I'm finding something inside my triangle, I need to use inverse. So I press shift first. Then I get sine with a little -1. Then it'll give me brackets, so I type in my fraction in the brackets. And that gives me
40 degrees.
40
Yeah. Just 40.
with any remainders, any point, blah,
Why
blah,
do you
blah.
have to put remainders?
Generally 2 decimal places is a good idea.
0.28.
Oh, you know what, that does round down. We'll just make it 40 degrees. But 2 decimal places is always the safe bet, especially for exams. Okay, so my son Kevin has decided to climb on top of our roof. Our house is 20 meters tall and I'm 50 meters away for some reason screaming. Now I need to try and figure out, right, sorry, I'm just changing it because I want to calculate that angle of elevation. So which one is elevation?
One from you.
Yeah, cool. The one from me to him, not him to me. Sorry, I decided to change it. Cool. All right. So I want to try and find this angle here. How do I do that?
Inverse.
Great. But first up, I need to name my sides because this forms a right-angled triangle. What side is this? And what side is this? Great. So what am I using? Soh, ka, or toa?
10.
Great, I'm using toa, so I'm using tan. So tan is equal to,
Opposite of adjacent.
so 20 over 50. So in my calculator, I press shift first. Then I press tan, and it'll give me tan with a little -1. And then in my calculator, I'm going to write 20 over 50. Great, awesome. 22 degrees. Great, so that's how big this angle is here. Cool. This particular story, we're looking for the angle of depression.
Yeah, it's fine. Calm down.
So I'm trying to find the angle of depression. So we've got a bird that this cat is eyeing off. And I need to try and calculate where is the angle that I'm looking for.
Above.
Yeah,
Whether
cool.
it's like
This one from here to here.
Yes.
That's the
Yeah.
angle I'm looking for. Fantastic. How might I figure that out?
Just
So
say,
you
10.
have your 100.
Yeah.
yeah. So it'll be so you
So
just
you
put
So
the
I'm
100 on
actually
top.
going to turn this
10.
into
Yeah.
a
So-
triangle.
You have to use 10.
You put-
10 minus. And
So
then
if it's 50 over here, it's going to
50
be
over
50
there.
over here. And if it's 100 down here, it's going to be 100 up here.
So you just
50 over 100.
Cool. So I'm going to turn this into a proper triangle just to make it easier for me to look at rather than dotted lines. So that's the triangle I'm looking at. And it forms a right angle. Cool. All right, so let's label our sides. This over here is
Opposite.
opposite. This over here is
Adjacent.
great. I've got it. So I'm looking for tan is equal to opposite over adjacent. So tan is equal to 50 over 100.
Yes.
In my calculator, I'm going to type shift, then 10, and I'm going to get a little -1, and it'll give me some brackets. So I just type in my fraction.
27 degrees.
Awesome.
Oh yeah.
Thank you. Cool. All right, so that will be 27 degrees.
Yes, don't you always round up if you can round up?
Only if the number is 5 or above. So if it was like 27.84, yes, 8 would round up, and this would become 28 degrees.
Okay. So if it's like
If it's
below 50,
4 or below, then it's then you just keep it rounded down. All right. So sometimes on maps, actually on any good map, you will see this symbol, which shows you basically which way to hold the map, so that you're always looking at north. Now, has anyone ever used a compass? They're a bit
Yes.
old school, but your phone has a compass, and basically it tells you wherever you're holding your phone, it will tell you where you are in relation to north. Anyway, so it's measured clockwise around like this. So north is 0 degrees. But bearings we always write in 3 digits for some reason. So this would just be 0, 0, 0. Now, if I was moseying along the road, I'm walking down here and I'm heading this way, what would my bearing be if I measure always from north?
90
Great, so I'm walking at 90 degrees. But bearings are written in 3 digits, so how do I turn that into a 3-digit number? Cool. Great. So that's how I write that bearing. Now imagine someone else, say Peter, is walking down here, and this angle
25
here
degrees.
is 20 degrees from here to here. How do I figure out what bearing he's at?
at 20 to 180.
Awesome. Great. So I measure from north, that's 90, that's 180. So it would be 180 plus 20. So from here to here, it would be 180 degrees plus 20 degrees. So he'd be at
200.
200. That's his bearing.
Good job.
Great. Any questions? Let's do one more. I need another color. All right. Say someone else is walking up this way, and this is
30.
sorry,
I like 30.
30.
Yeah.
All right. So old mate's walking up that way, and he's 30 degrees from north. What do I do?
360.
Awesome. Thank you. I could measure, go 90, 180, 270, and then try and calculate it that way, or I can realize that a full rotation is 360 degrees. So north is 0, 0, 0, and it's also 360 degrees. So I'm just going to take 30 away from 360 to find out where he is. So where's old mate?
330.
Yeah, cool. He'd be at 330 degrees. Cool. Any questions about bearings? No, they're not horrifying?
I like 30.
Okay, cool. All right, now let's do complex problems. There are a couple of these in your exam. So they take a couple of steps to do, but all you're using is these things here. You're not even, actually only these 2 things. So for the complex problems, you're only using these skills, finding sides and finding angles, but it's a multi-step problem. So I'm trying to find this. So my question says, find the value of theta. Now I can't do that yet because I don't have 2 pieces of information in my triangle to be able to find theta. So first I need to do something with this triangle up here. So any ideas what I might do? Peter?
You're trying to find the base.
Cool. So first up, I'm going to try and find the base of this triangle, and then I'll go from there. So what is this side over here in relation to this? That's adjacent. And what is this over here?
Opposite.
Yeah, cool. So this is my opposite side. So if I'm using adjacent and opposite, I'm using tan. So tan, I'm going to skip the working out step because that takes up too much space. So I'm going to go straight to tan. 61 is equal to, opposite is unknown, so I'm just going to call it, I'll call it x, over 15. Now my number's on the bottom, so what do I do? Move to the front. So now x is equal to 15, 10, 61.
27.06.
27.06. I'm just going to round it to my nearest whole number. Great. So that is how far it is from here to here is 27. Any ideas as to what I might do now? I know you know because we did a similar one, but any ideas from anyone else? What am I going to do? If I know that from here to here is 27, how do I use that to get the length of this? So if these two slices are equal, awesome. So I'm going to cut 27 in half, and that's going to be the length of this. So 27 divided by 2 gives me great. So that's how wide this is, 13.5. Now do I have enough information to find my missing angle?
Yes.
Cool. So I'm going to go ahead and do that. So I'm using, first I've got to label my sides. This side up here is opposite. This side over here is adjacent. So I'm using tan. So tan is equal to, I'll write out my 13.5 over 17. Now I'm trying to find inverse. So I have to push shift. 10 is equal to -1, 13.5 over 17. And what does that equal?
37.45.
Awesome. Is that horrifying?
That's a bit easy to understand, yes.
Salem, how do you feel? Good? Okay, so when you get one of these problems, break it up into sections, separate triangles to solve. If you want to do another one of these, you guys happy? Happy? Alright. Cool. Thank you for listening.